Hi everyone, welcome to our next video for week 4. We're going to discuss confidence intervals for the mean with small samples. So a few assumptions for this confidence interval. Um, First, we're assuming that our sample is a random sample, and we're assuming that either our sample size is bigger than 30, or we know the population is normally distributed. You will notice that knowledge of the population standard deviation is missing from that list. So everything we're doing in this video is assuming that we do not know the population standard deviation. So if we want to find this by hand, first we have to identify or calculate the sample standard deviation and sample mean. We're using the sample mean as the center point for our confidence interval. And we're using the sample standard deviation as a point estimate of that missing population standard deviation. For 2, we're going to find the t-score that corresponds to our confidence level. And we talked about that in the last video. So when you're missing sigma, it's a t-score and not a z-score. Next, we're going to calculate the margin of error. And because we're using t values, it's going to look just a little bit different. It's now t alpha over 2 instead of z. And we're using the sample standard deviation s instead of the population value. Otherwise, the structure is the same. Critical value times standard deviation divided by the square root of n. To construct the confidence interval, we do exactly the same as we did for one where we have sigma. Sample mean minus the error bound is less than the population value is less than the sample mean plus that error bound. Just like before, you should, at the end of this problem-solving process, write a sentence that interprets those values in the context of the word problem. What are we estimating? What do those values tell us? On your calculator or GeoGebra, the process is going to look very similar to what we did when we have sigma. On the 84, you're going to that same menu, stat test, except you're choosing option 8 for t interval. Just like before, you're going to enter the information given in the problem. It's going to give you a choice between raw data and summary statistics, and that'll depend on what the problem gives you. And then you're going to select calculate and press enter. For GeoGebra, just like before, you're going to have 2 choices. If you're given the sample data, you're going to use t mean estimate, and then sample mean, sample standard deviation, sample size, confidence level. If you have raw data, the calculator, or GeoGebra in this case, can calculate all of that sample information from the sample data. So you only need to give t mean estimate 2 pieces of information: the list where you put the sample data and the confidence level. Let's go ahead and do 2 examples so we can see what this looks like in practice, and we can practice interpreting our answers. So example 8.8 says, suppose you do a study of acupuncture to determine how effective it is in relieving pain. You measure sensory rates for 15 subjects with the results given. Use the sample data to construct a 95% confidence interval for the mean sensory rate for the population from which you took the data. So let's go ahead and sort out the information that we're given. So first thing that I see, I'm being asked for a confidence interval for the mean. So I see confidence interval for mean. So I know right off the bat, it's either a z interval or a t interval. To sort out which type of confidence interval I'm doing, I'm going to read through the rest of the problem and pick off what I'm given. So first sentence doesn't give us any values. It says, determine how effective acupuncture is. Second sentence says you measure sensory rates for 15 subjects with the result given, meaning they're telling us N is 15, but they're not giving us a sample mean or sample standard deviation. They're giving us sample data. They then say use the sample data to construct a 95% confidence interval. So we do know that our confidence level is 0.95. So to do this, we're going to go ahead and use a calculator. I'm going to use the TI-84 for this first example, and I'll use GeoGebra for the next example. So let's pull up our TI. We know that when we go to stat test and we go down to option 8, enter, it asks us, do we have data or do we have stats? We've got a list of raw data. First thing they're going to ask me is, where is that data? So I actually need to go back out and hit stat, and then in edit, I'm going to hit edit to enter that data in a list. So let me clear out the list that I have here, and we're just going to enter those values in list 1. Thanks to the technology of time lapse, we can see all of my values are in my table. If I go up to that last value, you can see it's in spot 15, which is good because we know we have 15 values. To construct that confidence interval, we're going to go back to stat and over to test and down to option 8. I'm telling it I have data. My data is in list 1. You should leave that frequency option as 1. And then we're going to enter our confidence level. This is 0.95, and then go down to calculate. And you'll notice it does a couple things. It gives us our confidence interval. So we should write that down. We know our confidence interval is 7.3006 to 9.1527. But it's also nice in that it gives us where that sample mean center is. That sample means at 8.227, and that sample standard deviation is 1.672. So it gives us those summary statistics for the sample data that we didn't have before. So let's go back and look at what the question was asking us. So it says, use the sample data to construct a 95% confidence interval for the mean sensory rate for the population. So based on the information that we're given, we know that the mean sensory rate is, or we can be 95% confident rather, that the mean sensory rate is between 7.3006 and 9.1527. So remember that on your paper, either handwritten or computer, you should type out or write out that sentence, reframing those two numbers in terms of what they tell us. So we know that the mean sensory rate for this acupuncture treatment is 95% likely to be between 7.3006 and 9.1527. So tell us what those measurements are and what they are estimating in terms of the work. Okay, so our next example says the Human Toxome Project, HTP, is working to understand the scope of industrial pollution in the human body. Industrial chemicals may enter the body through pollution or as ingredients in consumer products. In October 2008, the scientists at HTP tested cord blood samples from 20 newborn infants in the US. The cord blood of the in utero newborn group was tested for 430 industrial components, pollutants, and other chemicals, including chemicals linked to brain and nervous system toxicity, immune system toxicity, and reproductive toxicity, and fertility problems. There are health concerns about the effects of some chemicals on the brain and nervous system. The table below shows how many of the targeted chemicals were found in each infant's cord blood. Use this sample data to construct a 90% confidence interval for the mean number of targeted industrial chemicals to be found in an infant's blood. So, confidence interval. First thing I see that it's for the mean. So I know that it is a t interval or a z interval. To sort out which it is, I look at what I'm given. So second read through, first sentence tells us we're looking at industrial pollution in the human body. Second sentence tells us sample of 20 newborn infants. So n equals 20. The next number they give us is 430 industrial compounds. That's not actually any number we need for our confidence interval. It's just telling us how many compounds that they looked for. What we're actually interested in is this data table down here, which is how many of those 430 compounds were found in each of the infant's blood. So this table down here is the raw data from 20 newborn infants, meaning I don't know what my sample mean is. I'm not given a population standard deviation, and I'm not explicitly given a sample standard deviation. The lack of the population standard deviation tells me that I should be using a t interval. And then we're going to need the raw data and the confidence level. That's what our calculator needs. All of those other numbers, sample size, sample mean, sample standard deviation, the calculator is going to collect from that raw data. So this one we're going to do in GeoGebra just so you can see what that looks like. So let me pull up GeoGebra really quick. See if I can make this a little bit more user-friendly. Squishy it this way. Okay, so we're going to enter, first thing, our data in a list, just like we would on the TI. So I'm going to give it the name B because I've used A before. We use curly brackets for our data, and then we enter the data separated by commas. So now that we have our data, we know we want to run a t interval because we're missing that population standard deviation. So t means estimate. And I'm going to go back here and look, and I know it wants the sample name and the confidence level. So our sample list name is B, and we want to be 90% confident, so 0.9. And so we get a confidence interval of 117.411 and 137.489. So let's go ahead and jot that down, and then let's talk about what that means in terms of our problem. So the last sentence says use this sample data to construct a 90% confidence interval for the mean number of targeted industrial chemicals to be found in infant blood. So based on this confidence interval, we can say with 90% confidence that the true mean number of targeted industrial chemicals found in an infant's blood is somewhere between 117.411 and 137.48. So of the 430 industrial compounds, we expect the true mean to be somewhere between 117.4 and 137.5. Okay, if you have any questions on how to construct those confidence intervals for the mean, or how to tell whether it's a Z interval or a T interval, feel free to send me an email or text or drop by my office hours Tuesday and Thursday. Otherwise, I will see you in the next video.